Okay, so this is actually what you'll see on a test. And so we always kind of want to know what's on the test. So we should go ahead and tell ourselves that this is definitely going to be showing up on the test. And I think I've tried to do a good job of giving you hints. And so when I say test, I mean like my test, and I do mean the IB exam, because they do spend an entire section of the curriculum talking about this one thing. So, okay, how do we spot this? What are we looking for? How are we going to figure this out? Okay, first thing is that you're going to have multiple equations. So, like, here's equation one, and here's equation two, and both of them have their own delta H's. And then it's asking you to find the delta H for a third or fourth or fifth equation. So you might have anywhere from 2 to 4 equations. I think 2 or 3 is most likely. And then all of them are going to have their own delta H's. And then you're going to be looking for the delta H for a third, a fourth, a fifth equation. So what you do is you have to figure out where the target equation is. So this is always a problem. So the target equation in this particular example is at the bottom. So calculate the delta H for that reaction. So this is what I call this is my target equation. This is my goal. This is what I'm trying to figure out. Now, the problem is that there's no guarantee that your target equation is going to be at the bottom of the paper, right? Like it could be at the top. And so don't always look in this spot for the target equation, because it could very well be listed first. So it could be listed last, it could be listed first, but you're just looking for some sort of verbiage that is asking you to find delta H for a different reaction. So it could be on the top or the bottom. So what you're trying to do is you are trying to take the other equations, and so you got these two equations here. You're trying to take those equations and you are trying to get them so that when you add them up, put them together, they make this. Okay, so like this is the target equation, is basically the answer to an addition problem where we're just adding equations. So, okay, so when you do these, we have to remember a couple of things. Anything that I do to an equation, I can do to the delta H. So if I divide it by 2, then I divide delta H by 2. If I flip it over, I flip the delta H over, change the sign, stuff like that. So, okay. So what you're really wanting to do is you're wanting to find some sort of chemical in the target equation that is only listed once in the other equations, okay? And so if we look at the target equation, we have carbon here, oxygen, and carbon monoxide. And so we're looking for these things in here, but only in either this one or this one, but not in both. Because if we can figure that out, then we can manipulate the equation correctly, because it's going to be finding a unique item. So let's look at this first one here, carbon. So carbon is listed here and in the target equation. So it's only listed in equation 1. It's not in equation 2. So it's not down here. It's only listed in equation 1. And it's listed in the target equation. So we need it. All right. So what you're going to ask yourself first, is carbon on the correct side of the equation? The answer is yes. It's a reactant over here, and it's a reactant over here. So that's good. All right. Second thing you're going to ask yourself is, do I have the correct amount of carbons? The answer is yes. I have a single carbon, and I need a single carbon. So I have one here, I need one. So that's really good. So what that means is that your carbon has to stay exactly where it's at. It cannot move. You cannot change it. You cannot do anything, which means you have locked in equation 1. So let's go ahead and rewrite equation 1 down here. So carbon plus oxygen is going to turn in, well, I should probably do my states of matter. Bad habit to not write those down. So let's do carbon as a solid plus oxygen as a gas. And that's going to turn into our CO2. And this value has a delta H of negative 393.5. Now, students that do poorly on this do not do the bookkeeping. They don't write things down. So please, please, please do the bookkeeping. Do not take shortcuts. All right. So I'm writing this out because I'm keeping it. So I'm going to put a little check mark here because I cannot manipulate that anymore. That one is good to go. I'm going to keep it just like that. Because if I switch it, I'll never get this answer. Okay, let's look at equation 2. So we need to find something in equation 2 that's not in equation 1, but is in the target equation. Okay, so if we look, CO is not up here. There's no carbon monoxide. CO is down here, so that's good. See, I need the CO, the carbon monoxide, and it's not in equation 1, which means that whatever I do to equation 2, once I get it to match, it's going to be exactly what I want. Okay, so we're looking at the CO. So now we're going to ask ourselves a question. Is it on the right side of the chemical? Is it on the correct side? Is it a reactant or a product that matches the target equation? The answer is no. See, it's a reactant up here. So this is a reactant. And down here, it's a product. That's a problem. So what we're going to have to do is we have to rewrite the equation by flipping it over so that it's on the right side. So I'm going to take this equation here. I'm going to take this equation and I'm going to flip it over. I'm going to rewrite it flipped over. So let's go ahead and do that. And let's keep this equation in a different color so we can kind of keep track of it. So let's rewrite it. 2. So this is flipped over. So this is going to be on the other side now, right? So 2 CO2 as a gas. And so now it's going to be flipped over. So like the arrow's going this way, right? So it's flipping over. So then that's going to be a reactant. And so now I've got 2 CO as a gas. And I've got O2 as a gas. And then my delta H, I'm going to flip it over. So my delta H is not going to be negative anymore. I'm going to switch that, and it's going to become positive 566. So see, I switched the sign. So when I flip this, I have to manipulate that. So I have this. This is the key thing here. Okay. So now this is what we're working with here. So now this equation, I like to do it like this. I like to say, okay, well, this equation I'm not using, so I'm just going to cross this off because it's gone. I'm not using that one anymore. And we rewrote the first one. So these are basically gone. We're not messing with those anymore. We have these down here. Okay, so now we ask ourselves, okay, so looking at this one here, looking at that one, is the carbon monoxide on the correct side? It is. It's now a product, so that's good. So it's a product at the target, and it's a product here, so that's good. That's what we want. Okay, but do I have the right amount? Answer to that is no. You have too many. So you have 2 here, and you only have 1 there. So we have to match them to the target. So what am I going to do? I'm going to divide everything in this equation by 2. So we're going to divide this by 2. We're going to divide this by 2. We're going to divide this by 2, and we're going to divide that by 2. So I'm going to go ahead and rewrite it with all those things as divided by 2. So now it's going to become, well, 2 divided by 2 is 1. So CO2 as a gas, arrow. 2 divided by 2 is 1 again. So CO is a gas. And so now this is 1 divided by 2. So that becomes 1/2 O2. And then my delta H. So I'm going to take my 566, and then that also is going to be divided by 2. So this is where that bookkeeping comes in. And I know that you might be like, oh, I can do this in my head. And I'm like, yes, you can. What happens is if you make a mistake in your head, you're never going to see it. And so we're going to go ahead and squeeze that in right there. And then I'm going to go up here, and I'm just going to cross all of this off because this equation is now gone. So that's gone. All right, so let's check again. Is CO on the correct side? Yes. Do I have the correct amount of them? Yes, 1 here, right there, and then 1 here. So that's what we want. Okay, so what that does is that finalizes this equation, so it's also going to be locked in. And so now we should be able to add all this up, and we should be able to get our target equation. So just go ahead and draw a line underneath like this, like it's a big fat addition problem, and put a plus here, and we're going to squeeze this together, okay? Now, things on the same side add up, things on the opposite side cancel, all right? So if you have a chemical on both sides of the equation, product and reactant, they subtract from each other or cancel. If they're both reactants or both products, you add them up. So let's just go through and see what we build. Do we have any other carbons? No. Okay, so that carbon is going to be written down. It's not going to cancel, so I'm going to keep it. This oxygen, do I have any more oxygens? Yes, there's an oxygen right here. Okay, so what happens? So what happens is that they are going to be on opposite sides because one is a reactant, one is a product. So they cancel, they subtract. So it's going to be O2 minus 1/2 an O2. So they reduce each other down. So 1 minus 1/2 becomes 1/2. So 1 O2 here minus 1/2 an O2 there. They're going to go ahead and reduce to 1/2 O2. So I'm left with 1/2 O2 on the reactant side, the left side, because I have 1 here, and then on the opposite side, I have 1/2. So they just reduce down. Okay. So let's look at the CO2. So here's a CO2, and then here's a CO2 here. They're on opposite sides. They both have 1s, so they're going to end up canceling out. So they're gone. They reduced. 1 on the right, 1 on the left. Arrow. Let's look at our reactants. So that reactant's gone. Sorry, the products. This product is gone. So the only product left is this. There's no other COs. So write that down. And we check our target equation. Did we build it? All right, let's look. Target equation is right here. That's what we're looking at right there. So we've got a C, good. 1/2 an O2, 1/2 an O2, good. Arrow, okay, there's my arrow, and then 1 CO, 1 CO. Boom, it matches. Everything matches. So if it all matches up, which it does, then you're going to go ahead and just add your delta H's, and you'll get the right answer. So now that it matches up, I'm going to take this one, and I'm going to add them up. All right, so we get out our handy calculator. Negative 393, so it's going to be negative 393 plus 283. And I kind of like to write that down for you so that you know what we're doing here. So let's go ahead and do that here. So it's going to be negative 393.5 plus 283.